Welcome back, folks. We're going to look at, I'm going to try to summarize how I approach a problem when I'm performing nodal analysis. Okay, so this is another handout, just like I have for the mesh analysis one. It should be available on the website in my unedited notes, and I think it's pretty useful. I hope it is. If you're looking for like a 1-2 pager on things that you need to remember for nodal analysis when you first look at the problem. So let's do this. So not too often I use anything that's white, but I can scroll in on that one. For now, you can even see the web address up here and go from there. Okay, so the first thing I always notice is how many non-reference nodes. That's going to tell me how many unknowns I need to go after, and that's going to tell me how many equations I need to write. Then I got to figure out the type of equations that I'm writing. So I'm going to look for two things. I'm going to look for a voltage supply, okay, or multiple voltage supplies, and I'm going to write a KVL for each voltage supply. Now, some of them are grounded on one side, and that's the simpler of the two cases, and then some of them have two non-reference nodes on either side, and that's going to create a supernode. Okay, so that's going to change how I write the KVLs and KCLs. It doesn't change the way I write the KVLs. That's always the same. But it is going to change the way I write the KCL, whether I write it for the supernode or if I just write it for the other nodes in the circuit. Unique to nodal analysis, I'm looking for an op-amp, because if I find an op-amp, I'm also going to swap a KCL for a KVL. And that KVL is from one of the assumptions about ideal op-amps, in that the two nodes on the input have the same voltage. Okay? So that one's unique. So look for voltage supplies, look for op-amps. For each one of those, I'm going to write a KVL, make up the difference in the number of equations you need with KCLs, and know where to write them. Okay. When I write the KCLs, I got to avoid, do I have that in here? Hopefully somewhere in here. When I have to avoid nodes that have voltage supplies connected to them, and nodes that have the output of the op-amp. Make sure you know the difference between the output and the input. Okay? If there are any dependent supplies, I'm going to write an expression for the control variable, just like I did for mesh analysis. And I'm going to use that expression to substitute into any equation that isn't in the form of a bunch of constants and the unknown node voltages. All right, so once you have that plan, go ahead and write the equations, do whatever algebraic manipulation you need to. Pick out your favorite tool, MATLAB, TI-85, TI-84. That just, the 84 was, they could have done better with that calculator. The 89 is also wonderful. The 36 is pretty good. I have strong opinions about calculators. Anyhow, solve it. Find some way to solve it. And then use the output, right? So once you have the node voltages, use it to go find the other stuff that you're interested in the circuit. So if you're looking for a voltage, then all you have to do is say, where am I sticking the red probe? Where am I sticking the black probe? So what's plus and what's minus? Subtract the minus one from the plus one, and that's your voltage. So I think the voltage is the easiest thing to go after with nodal analysis, once you know the node voltages. If there's a current through a single passive component, okay, so resistor, capacitor, inductor later on in the class, then we're going to do a combination of KVL and Ohm's law, and that's the one where I have the refrain of saying voltage at the tail minus voltage at the tip over the resistance. Okay, so we can do that pretty simply if it's a single component. If there are multiple components, or if you're looking for the current through a voltage supply or an op-amp, then you're going to have to do some combination of these. So multiple components, if you're trying to find the voltage, well, that's still the same. Take the one on the positive, subtract the one on the negative, and that's your voltage. If you're looking for the current through a voltage supply or an op-amp, you're going to have to write an additional KCL. And it's a KCL that we may have avoided in the first place, but now once you know the node voltages, you can go ahead and write that KCL. You add one equation, you add one unknown, and you can solve the system for the value you're interested in. Okay, This stuff takes practice. If all you've done is watch videos, you're not going to be good at it. You've got to go do the homework. You've got to, we'll practice in the live sessions. I always like to say if I can get you to work 100 problems, you'll be an expert. Truth be told, I can usually cram about 70 problems into a semester, and I'm going to. So anyhow, now you know how to do analysis in 2 ways. That's fantastic. We're going to move on to theorems, so look for that video. Hopefully you're feeling good about this stuff. Stay tuned and good luck.